Laying down some million-dollar cable. Southern Cross Cable Network says it will begin the construction of a $350 million submarine cable after finding a more efficient route across 15,000 kilometers of seabed. The Southern Cross next subsea cable route will connect Sydney, Auckland, and Los Angeles through the Wallis and Fortuna waters. Subsea cables handle 99% of data traffic sent around the world. That includes internet usage, phone calls, and text messages. Underwater cables are faster than satellite transmission by up to 8 times. The cables are much thicker near shore because they can be easily damaged in shallow waters by ships and sharks. The cables are laid on the ocean floor by cable-laying ships along a pre-surveyed route that is designed to avoid coral reefs, shipwrecks, and deep trenches. The new cable is said to be able to offer the highest capacity and lowest latency internet connection for Australia, New Zealand, and several Pacific Island nations. Keep watching to see the different ways we stay connected. SpaceX plans to launch thousands of internet satellites. SpaceX has filed an application with the U.S. Federal Communications Commission to launch thousands of satellites in order to provide high-speed internet coverage worldwide. SpaceX's satellite system consists of 2 sub-constellations of space stations. The first, known as the LEO constellation, would be comprised of 4,425 satellites in an orbit of at least 1,150 kilometers above the Earth. Each satellite can provide service up to 43.95 degrees away from bore site. The second, VLEO constellation, would include 7,518 satellites, orbiting about 335.9 kilometers above the Earth. Each satellite can provide service of up to 51.09 degrees from bore site. The satellites in the LEO constellation can cover approximately 4.5 million square kilometers, while those in the VLEO constellation can cover less than 1/10 of that area. The system is designed to provide broadband and communication services for private and professional users worldwide. The deployment of the satellites is expected to begin in 2019 and be completed by 2024. Google and Facebook join forces on undersea data cable. The network of deep-sea Pacific Rim cables that help connect the web and keep it global is about to get bigger, with a little help from Google and Facebook. The deep-sea Pacific Light Cable Network will stretch across the Pacific Ocean between Hong Kong and Los Angeles. The cable will use new fiber optics to transmit large quantities of data, forming the first direct deep-sea cable network between the 2 cities. Normal fibers transmit data on the C band. The new fibers will send data in both the C and L bands, which developer TE Subcom says effectively doubles the bandwidth available. The cable will be able to handle up to 120 terabits per second. Google says that's enough bandwidth for 80 million concurrent video conferences between Hong Kong and Los Angeles. When it's completed in 2018, the cable network will span some 12,800 kilometers between the cities. Facebook and Google have teamed with TE Subcom and Chinese company Pacific Light Data Communication to develop the Trans-Pacific Cable. Tech giant experimenting with signals 40 times faster than 4G. The Guardian reports that Google is experimenting with drones that could deliver internet speeds up to 40 times faster than 4G. The Google project, called Skybender, is using Spaceport America in New Mexico to experiment with delivering high-speed internet from the air using its 50-meter wingspan Titan drones. The drones are equipped with millimeter wave radio transmitters, a technology that could feature in next-generation 5G wireless internet. Optionally piloted Centaur aircraft are also being used. Millimeter wave technology has the potential to transmit gigabytes of data every second, with speeds up to 40 times faster than 4G internet. However, millimeter wave signals are absorbed by atmospheric gases, while rain and humidity can also reduce signal strength. Millimeter waves also travel via line of sight, which means they can be blocked by objects, including trees and buildings. The report says Google has permission from the Federal Communications Commission to continue testing in New Mexico until July.
Facebook considering lasers to connect the next billion people. Mark Zuckerberg announced on Wednesday that Facebook is considering using lasers on drones and satellites to connect the next billion people to the internet. People in developing countries are more likely to connect to the internet using mobile phones instead of computers. Initially, Facebook considered satellites, which work best for low-density areas. For suburban areas, the company is considering using drones, which fly at a much higher altitude than commercial airplanes, at around 20,000 meters. These drones, which have a wingspan greater than that of a Boeing 737, are solar-powered and can remain airborne for months. On both the satellites and drones, Facebook would use lasers to beam data through the air and provide high-speed connectivity similar to that of fiber optic networks. According to Zuckerberg, the laser beams won't actually be visible but will allow users to send data at dramatically improved speeds over longer distances.
Li-Fi could replace Wi-Fi as faster internet delivery system. A new form of internet data delivery is making its way to the market, and it might replace Wi-Fi in the coming years. Li-Fi, or Life Fidelity, uses LED light bulbs to send information, and theoretically can deliver internet access 100 times faster than Wi-Fi. LED light bulbs emit visible lights, which is a constant stream of photons. When the current is manipulated to create slight fluctuations, a photodetector device can pick up the pulses to convert them into an electrical current. However, because Li-Fi uses only visible light, it does not work through walls, nor will it work outdoors in the sunlight. In the future, light bulbs could become wireless hotspots and could be utilized on aircraft and in other places where radio signal interference is an issue. Due to its limitations, initial usage of the technology may be restricted to crowded urban areas or in areas where Wi-Fi usage may not be safe, such as hospitals.